Hi, my name is Muhammad Amirul Adli.
Hi, my name is Said Nabi Fahimi.
Hi, my name is Jasmine Ibina.
Hi, my name is Muhammad Hakimi.
The title of our selected topic is Newton's Law of Cooling or Warming. It states that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the surrounding temperature. The model expressed as dt over dt equal to k T minus Tm, where Tt is the temperature of the object at time t, Tm is the temperature of the surrounding object, dt over dt is the rate of change of the temperature, T minus Tm is the difference between the object's temperature and its surrounding temperature, and lastly K is constant of proportionality.
Oh, our drink is ready. Let's go.
Stop, Nabil!
Why, what's wrong?
Did you know drinking coffee that above 70 Celsius could cause a serious damage on your tongue?
Oh, really?
Yeah.
That's right. This is a perfect real-life example of ordinary differential equations that we've learned in class.
Really? In class?
Yeah, through Newton's law of cooling, it says that the rate at which a drink cools is proportional to the difference between its temperature and the surrounding temperature.
Can you make it simple, please?
Well, basically, hot things cool faster when the temperature difference is higher or bigger.
Oh, I see.
Oh, really? How did you know that?
I actually saw a video on YouTube explaining ordinary differential equations problem.
Can you show to us?
Yeah. Today I'm going to be explaining how to solve a first-order differential equation using the method of separation of variables. The equation we are solving models temperature change over time and is commonly used in real-life applications such as heating and cooling processes. This equation shows that the rate of change of temperature depends on the difference between the object's temperature and the surrounding temperature. I will go through each step, showing the calculations clearly and explaining the reasoning behind each step. So we are given the differential equation. This equation simply means that the rate of change of temperature with respect to time is proportional to the difference between the object's temperature and the surrounding temperature. So, to solve this differential equation, we move to the first step, which is to separate the variables. So we use the separation of variable methods by rearranging the equation so that all terms involving temperature are on one side and all terms involving time are on the other side. So from here, we get 1 over t minus tm dt equals to k dt. After that, we must integrate both sides with respect to their variables. So, after integrating, we will obtain ln t minus tm equals to kt plus c. Moving on, we must eliminate the natural logarithm by exponentiate both sides of the equation. Using the laws of exponents, this simplifies to t minus tm equals to exponent to the power of kt multiplied by exponent to the power of constant. Since exponent to the power of constant is still a constant, we name it as a. Therefore, we can simplify it again by t minus tm equals to a exponent to the power of kt. Finally, we rearrange the equation to make t as the subject. From here, we know that t equals to a exponent kt plus tm. In conclusion, this final equation shows that the temperature changes exponentially with time and gradually approaches the surrounding temperature Tm. The constant K controls how fast this change happens, while the constant A depends on the initial temperature of the object.
Oh.
So, how do I know when is it safe to drink my coffee?
Actually, it is very simple, Nabil. But first things first, can you open the cup for me? Okay, first we need to calculate our surrounding temperature. So by calculate our surrounding temperature, we got 33 Celsius. And then we need to calculate the initial temperature of this coffee. And we got 90 Celsius. And then we wait for 10 minutes.
Approximately 10 minutes later.
And after 10 minutes, we got 70 Celsius of the temperature for our coffee. And that's all the information we need to know when to drink your coffee, Nabil.
So Kimi, how do we use all the information on this model?
Actually, that's very easy since we have the model ready. Let me show it to you guys. Okay, first thing first, we need to list all the information that we had measured, which is at the time 0, our temperature of coffee is 90 Celsius. And after 10 minutes, our temperature is 70 Celsius. We need to convert the 10 minutes into hours, so we divide by 60. And the thing that we want to measure, which is we want to know at what times the coffee will have a temperature of 50 Celsius. So we also calculate the surrounding temperature at that times. It gives us 33 Celsius. And by using the model that have been explained by Jasmine in the previous video, we got our general solution is T at the time T equal to A exponent KT plus 33. So we are moving to the next part, which is we want to apply the condition that we have to find the values of A and K. We have two conditions here, which is at the T0, we got 90 Celsius, and at the after 10 minutes, we got 70, which is T 10 over 60. So we substitute the value of T0 equal to 90 Celsius to find the values of A, and we got A as 57. And we move to the T 10 over 60 equals to 70, and to find the value of K. And it will give us K as negative 2.5928. So next, we will substitute the values of A and K that we got from the previous calculations into the general solutions. That will give us the equations that describe the temperature of the coffee at the time T. So we got our equation as 57 exponent negative 2.5928 T plus 33. So to achieve our final objective, we will find the T when the temperature is 50 Celsius. So to do that, we use the Tx equal to 50 Celsius. We substitute it into our equation that will give us the value of T, which is the times when the temperature of our coffee is at 50 Celsius. So after do the calculating, we get our value of T is 0.4666 hours. We will convert this amount into minutes by multiply it by 60. That will give us 27.996 minutes, which is equivalent to 28 minutes. So the time taken for our coffee to reach the temperature of 50 Celsius is after 28 minutes. So that's all from me. Bye-bye.
Go. Hold on. I want to add something special. Drinking coffee that is too hot can cause thermal injury. Other than that, it can significantly increase the risk of esophageal cancer due to repeated cell damage in the throat lining. So be careful before you drink your coffee. Bye.
Oh, so now I can drink my coffee after 28 minutes.
Yeah.
Hi, so we have from just as we did in the first two.